I'm very excited to be here today with Andrew and announce Elorian to the world, which is a company he's co-founded. Andrew spent the last 14 plus years at Google. He wrote a paper that formed the backbone of GPT. He led pre-training for Palm 2. He was the data lead for Gemini. Has a whole host of experiences that led him to this point today, which was founding a company that is a leader of multimodal reasoning. We'll get into what it means to be a multimodal reasoning model, what he's doing. I thought we'd start off just learning a little bit more about you, Andrew. Walk us through what you did at Google. You have quite an accomplished background, and I think it's important to hear more about what you did, what you accomplished, and what you learned along the way to kind of get you to this point today.
Cool. Well, thanks for the intro. So I've gone through quite the journey at Google. Initially, I was in a team that did news recommendations. Eventually, it became Google Now. At the beginning, it was called Taba, which was slightly ahead of its time. But I always knew I wanted to go back to AI, which was what my PhD was in. So a couple of years after I joined Google, I joined Google Brain. Then it was still a very small team, just 40 or so people.
When was that? Yeah.
That was back in 2014, 2015.
Wow, okay.
Or so. So I got the chance to overlap with some amazing people, including Elias Saskava and Oriol Vinyols and Quad Clay. And Quad Clay was the person who I first worked with, and one of our first projects together was this paper that came out in 2015 on language model pre-training and supervised fine-tuning. And that paper laid the groundwork for GPT in conjunction with the Transformers paper, everyone, of course. But after that, I spent some time on Smart Reply and Smart Compose, which were some of the earliest generative AI products. Spent a few years in Google Health. Again, worked with some great people, including people like Liam Feathers, Demi Guo, and David Ha. Then after that, I worked on some of the earliest mixture of experts LLMs. So GLAM, which was the first mixture of experts LLM to be competitive with GPT-3. And then I worked on PaLM, co-led PaLM 2, pre-training lead for PaLM 2, as you mentioned. And after that, Jeff Dean asked me to step up to be the data area lead for Gemini. So since then, I've been spending all my time on Gemini. I've been publishing less since there are obviously more competitive restrictions there. But I also had the pleasure of working on the modeling for Search AI overviews and synthetic data in Gemini as well. So I've touched a whole bunch of things up and down the LLM stack for the last decade.
Awesome. Well, you had all the resources available to you at Google. You've been in this field since before it was cool. Talk to us a little bit about the insight that you had, right? You wanted to build a new lab with a focus on multimodal reasoning. Why do we need a company focused just on multimodal reasoning, right? Everyone is, from the big labs to the neo labs is kind of going after all these opportunities. Why did you see that as an important enough problem to focus an entire company around?
Yeah, so I've been working on text models, essentially, traditional language models for more than a decade. I think they took a real leap last year when reasoning from 0103 series first came out. But even then, we could see areas where it wasn't quite like human reasoning. So even if people found that even if the chain of thought is wrong, the model can still produce the right answer. And vice versa, if the chain of thought is wrong, or if the chain of thought is correct, the model can still produce a wrong answer. And obviously, we know that's not how human reasoning generally works. But one thing that really stood out was that in any kind of reasoning situation, we are not thinking purely in language, right? So as a designer, say you're an interior designer or an architect, you might visualize how a room is going to look. You might plan it out in your head. Even for software engineers as well, for really complex system designs, you don't describe them to your boss as a set of code or a full block of text, right? You always draw diagrams, you always draw boxes around how the relationships between the different parts of the system connect together. And that's what I noticed was kind of missing from these models, that they were operating purely in this language space, which is quite different to how humans full-fledged reasoning works, and I also believe that's how human reasoning developed. I believe it developed from working with the physical world, working with the natural world and our vision systems, to eventually arrive at the reasoning capabilities we have.
Awesome. So give us the 30-second or 1 minute kind of like pitch on what is Elorian, right? What does it mean to be building a multimodal reasoning model?
Yeah, so Elorian is a research and product lab. So what we are doing is we are aiming to build visual AGI. So this is a part of intelligence has commonly been overlooked, especially in the last few years with all the emphasis on coding, math, and legal applications. Visual applications are actually a big part of the human experience and human technology and human endeavor, right? Like it's very hard to imagine how you can design like a faster rocket with pure code, right? The real world doesn't work on this one-dimensional axis of language. It works in a three-dimensional world, and to make things that actually work in the physical world, you have to really understand how that works, both in terms of the physics of the world, but also in terms of connecting that with human language and human concepts. So we think that's very important, and there's many applications you can imagine, from engineering through to design, various types of image analysis, and of course robotics is a more recent application that can use this kind of capability.
Yeah. So talk to us, share a little bit more. Is this similar or different to these world model companies, the physical intelligence, the skill, the world labs? Is it like how similar or different is it to kind of these companies building world models?
Yeah, that's a great question. I think world models, what we've seen coming out of world models has been more focus on robotics and working with the natural world, with applications in, say, entertainment, and those kind of areas. But really, we believe that the right approach is taking a foundational model approach. So building a model that's very general, but very good on a specific set of capabilities. And the capabilities that we are targeting are specifically for reasoning. So we want to have the model not only be able to recognize that this is a bird or this is an animal, or that if you drop a ball, it will fall, but we want to connect them all together. So given like a visual scene, you can imagine some text that says, oh, if you make this, say, robot arm a little shorter, it will have less degrees of freedom, but it will save energy, right? So this kind of interaction between different modalities is really missing. I believe world models tackles the physical or the visual modality alone very well. But we believe that really what we need is to combine the modalities in a seamless way, and that will give us the next step up in terms of reasoning.
One of the things I wanted to get into later, but it makes a lot of sense to to talk about it now. It seems like you took a little bit of like a contrarian approach, which was the way to handle visual reasoning isn't to first convert those inputs to text, then do reasoning across that text, but to do actual reasoning on the image or the video or the sensor input data itself. Can you talk a little bit more about the decision to do that, what it unlocks, and kind of why you decided to build that way?
Yeah, there's been a lot of work in the reasoning domain. So in academic terms, this has been work, say, on latent reasoning, pioneered by several people in industry. And of course, the other one is chain of thought reasoning in the text space. But really, one area that hasn't been explored very well is reasoning in the actual visual space. And we believe there's a lot of potential there, because Yeah, so if you look at reasoning in the natural world, outside of just human reasoning, a lot of this reasoning is done in the visual space. So say an eagle, when it's flying out in the world, it has to do a lot of very complex physical world reasoning and natural world reasoning. So it has to be able to predict the trajectory of a sparrow that it wants to chase and hunt down for its lunch. Or like if there's a mouse running through a field, it has to be able to predict which direction that mouse is going to move to, because it takes the eagle maybe a few seconds just to reach the mouse. So it needs to do all these complex reasoning steps. And the bird brains are relatively small compared to human brains. So the logical thing it would be doing is doing this in the visual space rather than on some other latent representation space. And as you can see, our models still aren't able to do all of these tasks, right? They have trouble understanding even gravity. So we believe that with the correct grounding, with the correct representation for reasoning, we can really unlock a whole new set of capabilities for our foundation models.
Yeah. And I have to imagine as well, alongside that, it will actually also make the reasoning on multimodal inputs more performant, more cost effective, not just more capable.
Yeah. By building a specialist model, so as opposed to the very general but very capable models that Google, OpenAI, and as Rebecca pointed out, we are able to build smaller models that can be more efficient by not emphasizing the other capabilities. So that can make us build more cost-effective models specifically for these kind of capabilities.
Yeah. One of the things that we talked about, I remember when we first met, were some of the trade-offs larger labs, larger models make when it comes to whether it's data or training techniques to make models better at text reasoning or coding. Kind of comes with a trade-off in kind of multimodal capabilities. Can you talk to us about, and I think it's another argument for why we need a specialized company just focusing on multimodal reasoning, just some of the trade-offs companies make when it comes to optimizing for one task versus another?
Yeah, so the way this works, and I've seen it a lot of times working in the data area, is that we have to make decisions on a daily basis about which data sets to add, which data sets we might be removing from the data mixture. And this isn't free. So every change to the data mixture makes some things green on the metrics, some things red. And so we have to constantly be making these decisions. It's not always like the thing people might envision, where if you add more data, you always get a better model. It's much more subtle than that. And so every frontier lab right now is making their own set of trade-offs and decisions about what's important to them. And that means that that is what you have to do as a generalist model. You have to satisfy all the potential use cases, especially for consumer models. You have to satisfy all the potential use cases anyone can think of. But being very focused on visual reasoning, that means that we can potentially say, oh, we worry less about the model knowing like which battle occurred like in the 1800s, or who was winning the NBA like a few years ago, things like that. Those kind of general knowledge questions and general knowledge information. And we can focus both the data, but also the model architecture and the algorithms very much on having exceptional multimodal capabilities. So that's what we're able to do by being so specialized.
Yeah, awesome. So I certainly have a belief that reasoning across images and videos, and just in general, like multimodal inputs, will become a huge bottleneck. And there's a lot of stuff we can't do today that we will be able to do once companies like Elorian exist. But talk to us a bit about how you envision or how you expect people to use your models. Like, what are some of the use cases that become unlocked in a post-Elorian world?
Yeah, so as I mentioned, we expect to have use cases much broader than world models. So some of the immediate ones that we have seen that could be very beneficial are the engineering world. So the engineering world is very interesting because you both have to be very good at reasoning about physical processes, about the physical world, but you also need to be very good at understanding visual diagrams and schematics and things like that. And that comes about because you can't just design a airplane wing in pure code. That's just not how the physical world works. So it's fundamentally different from the world of coding. There are also other applications. For example, in robotics, understanding, say you have a robot going into a factory control panel for some safety issue, and humans can't be there. You need to make some split-second decisions, right? Do you trust a very basic model to just push the right button, or do you need a reasoning model to really reason about, maybe I should pull this lever to enable the safety safeguards before I start operating on this control panel. So that's the robotics use case. And there could also be potential use cases and things like wildfire management and detection from, say, satellite imagery. So there's a whole load of industries and applications right now, which are essentially bottlenecked on the progress of these models. And as a result, they become very labor intensive. And it prevents very capable people from doing more with their abilities. So that's really what we want to unlock. Ultimately, we want to have people be able to use their skills more effectively and have this AI help with some of the work that is less interesting.
Yeah. Quite cool. I want to get into maybe shift gears slightly here. The other week, Cursor was in the news a lot. As people started to question whether they were pre-training their own models or post-training open source models. Again, in a lot of companies now, whether it's Neolabs or application companies, are kind of building and developing their own models and their own model technology. How do you think about your approach? What weight will you assign to kind of post-training? What weight will you assign to pre-training? I imagine it's some combination of both, but how do you want to balance kind of pre-training and post-training at Elorian and kind of sequence that out?
Yeah, that's a good question. I think that's on the minds of a lot of people at these labs. What we see is that for the approach that we're building, it's enough to post-train first. And we're already are seeing some signs that this is an effective way to improve the visual reasoning capabilities. But ultimately, to maximize the model's performance, we do expect we will need to do pre-training later on. And the team already is built for that. So we have a full stack team with decades of pre-training experience and post-training data infrastructure. So we believe we'll be ready for that when it comes. But I think there's no need to rush into it. Well, to do pre-training correctly, you have to be very careful in things like data preparation, data sourcing, model architecture optimization. So we're fine doing that in the later stage.
Yeah. I want to talk about a little bit of tap into your recent learnings and insights. So you mentioned data now a few times and how important it is to pick the right data. You can't just throw more data at the problem and expect it to get better. But what are some of your core insights and learnings when it comes to data that you've kind of gathered over your quite successful career that you want to take with you to Elorian? Without getting into the secret sauce. Yeah,
I can't talk too much about the secret sauce from Gemini or my previous work. But one thing I would say, probably biased by the training I had. So my PhD was in Bayesian nonparametrics, and that taught me to think in a very statistical way, to think about data, not in terms of individual data examples, like this example is right or this example is wrong, but really think about the distribution and distributional effects. And I think that's been very valuable. So I would say I kind of think about data and architecture and optimization slightly differently. I think of data as essentially a statistics problem, and I think of architecture and optimization as a basically an optimization problem. And I think this kind of view has been very successful. But I can't talk in detail about
Yeah, of
what
course.
is the correct distribution.
Yeah. It's super interesting because I know you meet so many companies that try to innovate on different vectors, different layers, and the answer always seems to be the best companies are able to optimize all of them.
Yeah,
And
absolutely.
so excited to see all the progress that you make in both kind of like the algorithms and the architectures as well as the data side. And then reading the the story 10 years from now where we can actually unpack all of the learnings and some of the secret sauce. I just kind of want to hit a couple like rapid fire questions on just topics that are coming up more and more when I'm chatting with researchers, when I'm chatting with founders, or just kind of folks generally in kind of like the AI research space. But one of them seems to be this concept of like recursive models or like self-improving models. How do you think about those techniques or architectures in the multimodal space, and maybe even to some extent, specifically how you think about their application at Elorian?
Yeah, so we think there's a lot of potential there in the multimodal space. And that comes about because to get to the stage of recursive self-improvement, you essentially need to have some prerequisites. So one is you need to have something that's verifiable. So you need to be able to produce problems where you know the answer with 100% or close to 100% accuracy. And that is true for many multimodal problems. And the other is that there needs to be a fast cycle time in iterations. So one obvious example for this is the world of coding. So in coding, you can produce things that are verifiable through tests. There's also a very fast cycle time because code is fast to execute, right? You see less of this in the physical world, like robotics, because you're dealing with like actual hardware that takes time to manufacture, takes time to assemble, until we have like robotic assembly plants, right? But in the multimodal world, I view it as more like in between these two worlds, where we can have verifiability that doesn't go all the way to the physical world, but goes partly to the physical world. In the multimodal world, we see there are opportunities there. So we have a verifiable part by the way we can construct the problem, but we can also have a fast cycle time by not going all the way through to the physical world and building something physical. But still, it will be closer to the real physical, real natural world than coding is. So we see this more as like a stepping stone towards recursive self-improvement for the physical world.
I thought I said I wouldn't ask any more questions on data, but you know so much about it, and I keep thinking of more questions to ask you in that regard. Is there a difference between data that will make a model perform better on a benchmark versus data that actually makes the model useful in kind of like real world contexts and settings, and kind of how do you think about like the benchmark maxing versus making the models like actually more useful and applicable to end users?
Yeah, this is a very complex question. And there are many sides to this. So let me start with an example of, say, high school exam. So say you have a high school exam, and some of the questions that, or middle school exam, some of the questions that are multiplication questions. Say they are 2-digit multiplication questions, or maybe 1-digit and 2-digit multiplication questions. If you were very strict about your evaluation, what you should be doing is you should be removing these particular multiplication questions from your data. or your entire data set, your pre-training, your post-training, everything. But then say you remove the data, what is 6 times 9 from your data sets, obviously it's going to be much harder for the model to learn that specific thing. And you can easily ask, is that the right thing to do? Other examples are, say you have a evaluation question, which is like, who was president in 2016, right? Do you really want to remove that from your training data set, right? So this is actually a very complex question.
Yeah.
I would say the solution is to think beyond of what we're currently doing, which is using the same benchmarks we've been using like even before ChatGPT existed, right? I think what we should be doing is we should be constantly developing new benchmarks. At least every year, we should be then probably setting expiration deadlines on older benchmarks, and we need to constantly refresh our evals. If you just stay with the same evals, it's inevitable that there will be benchmarks, either intentionally or unintentionally, because everyone puts these on the internet, everyone uploads these into GitHub, and it can be very hard to remove all of that from the training data.
That's interesting. Are there any benchmarks that you care about today in the multimodal reasoning space? Do we need to create those, or how ultimately are you going to measure how successful your models are that you're building?
Yeah, so some of the one of the more recent benchmarks that we've seen that have more correlation to the real world is one called Baby Vision.
Baby vision?
Yes, Baby Vision.
When are we going to have teenager vision and adult vision? Those will be the next versions of the benchmark.
Yeah, yeah. So Baby Vision evaluates kids of 3 years old, 6 years old, 9 years old, and 12 years old.
Okay.
And the latest results show that no models can perform even at the level of a 6-year-old. So we're quite far away from adult level visual reasoning. I think this might be a surprise to some people given the results on RKGI.
Yeah.
But for people who've actually played with RKGI, you'll notice that it's on a pixel grid. It's on a relatively small grid, nowhere near the resolution of the human eye or actual problems that we see in the real world. So I think Baby Vision is a much more representative eval for visual reasoning. But I'm sure that even with Baby Vision, right, it will get saturated over time. So I think we still need to continually develop new evals as well. And at Elorian as well, we view evals as critically important to understanding models and really being able to measure the progress effectively. So we also plan to release our own evals to contribute back to the community.
Awesome. So if today we're at the visual reasoning, models are at a visual reasoning capability of a 6-year-old, what's holding him back? Is it data? Is it model architecture? Is it something else? Like what's stopping us from having kind of like the ChatGPT moment for visual reasoning and kind of getting, Baby Vision to the visual reasoning capabilities of an adult?
So actually, they haven't reached the capabilities of a 6-year-old yet.
Oh, okay, yeah. Okay.
So
it's not even that good.
Yeah, exactly. But yeah, we think that it has to be a combination approach. Like just starting more data isn't really sufficient. There are things we need to improve on the architecture, on the algorithm side. These models have really been specialized for language over many, many years. And so there are some fundamental things that still need more work, right? So like having one model produce both language and images and video, that's what we see as a stepping stone towards visual reasoning. That's one of the things that we're looking to build. I think you see also that the thing is, language is very easy to work with, right? It's text, it's tokens, you can filter it with regular expressions, it's cheap to store. Multimodal data is very big, very expensive to work with. You can't regex your multimodal data set, right? So I think there's going to be more and more techniques that need to be developed to filter the data, process the data in large volumes, and also to have the architecture, like the mixture of experts, handle that kind of data well. There's been very limited research into that.
My own personal baby vision benchmark will be when I can take a video and upload the video to ChatGPT and ask questions about it, then the models are probably getting better on visual reasoning. But I remember when we first met, I was kind of surprised because I know I can take pictures and ask ChatGPT questions about the pictures, but you can't do it with a video. And I found myself in a garage door broke, and I wanted to take a video of the garage door opener and send it to ChatGPT and say, like, what do you think's wrong? And I couldn't do it. And that was one of many reasons I kind of got so excited about the opportunity in front of Elorian and what you're building. Maybe last question for you here, Andrew. You're starting a business. A lot of the early success will be driven by the people and the team that you can recruit to this mission to work on this company and product with you at Elorian. What would you say to folks out there today that are thinking about joining a young, up-and-coming neolab like Elorian versus an OpenAI, an Anthropic, or a Google where you used to work? Like, why should folks come and work with you versus one of the larger labs?
Well, great question. So compared to the larger labs, we are much smaller. We can be much more focused. One thing I would say about the large labs is that there's a major tendency to have more specialized divisions in the frontier labs. And that's not saying that's the wrong way to do things, but that's just how they can be effective at such a large scale, right? So if you work in post-training, you don't look at pre-training, you don't really look at the model architecture. That's all handled by other people, other teams, and you're quite distanced from that. Even if you work on, say, pre-training data, you don't necessarily have much interaction with people in post-training who might be using similar parts of the data, right? So these are different worlds in the large lab. But in our company, we are building a very small, nimble, and focused team who are willing to go full stack and understand the problems end to end. And this is very important when you're building a new capability, right? Because this new kind of, say, image reasoning data, it might not be effective unless you fix something in the optimization or in the mixture of experts architecture or your RL reward, right? So it really pays off to have this kind of like end-to-end view of the problem. And we're able to do that at Elorian by having such a small team and a lot of people who have full stack expertise as well. And then compared to other neo labs, I would say we are one of the teams with the most experience working on frontier state-of-the-art models. We collectively have decades of experience working with large language models. And I think that's very rare to find, except in the big frontier labs.
Awesome. Well, Andrew, thanks for being with us today. I think what you're building at Elorian will become incredibly important as we all march collectively towards AGI. And maybe most important, I'm excited to see you come out with not baby vision, but maybe teenager vision and adult vision and just whatever comes after baby vision.
Yes, and yeah, it's been great chatting with you. Thanks so much for the interview, and yeah, we are looking to build the next generation of reasoning models and the evals that will really show that.
Awesome.